Hi guys, here we are with the review packet that I handed out on Friday. It basically has a ton of different problems in it. The first page has you figuring out what kind of a series you have, and then figuring out the sum based on what formula that you need to use. The second page has a bunch of sigma notation problems, and then the third page has some word problems. So I'm going to do the first three problems on the first page because it shows us one of each of the three types of series that we are studying. That'll be the first video. The second video will be a couple sigma problems, sigma notation problems, and then the third video will be some of the word problems on the last page. So here we go. First, we need to identify what kind of sum we're finding. And the dead giveaway here that this problem comes from section 9.2 is the fact that there's no ending term. So that tells us that it is an infinite series because it has no end. And also I can tell that it's a geometric because it seems to be multiplying by 1/3 every time. If you forget how to do that, take 9 divided by 27, take 3 divided by 9, take 1 divided by 3, you should get 0.3 repeating. So in this problem, our R is 1/3, and U1, the first term, is 27. It says, what type of sum are you finding? Infinite geo, write the formula. That's going to be the sum of this infinite series is U1 over 1 minus R. So it's going to be the first term, 27, divided by 1 minus 1/3. So we have 27 divided by 2/3, and our answer is 40.5. So the sum of that infinite series is 40.5. Now I'm going to jump down to the third one because it's pretty similar in that it is geometric again. So we do have a geometric. This time our R, if we divide 9 by 3, divide 27 by 9, and so on, we find in this problem that R is 3. So if this series didn't have this little 729 on the end, if this was an infinite series, it would not have a sum because this R is not in that accepted range from -1 to 1. However, when it does have a stop, an end in sight, that makes it a finite geometric series. And that's what takes it into section 9.3, which has this formula. The sum is, you still have the U1 over 1 minus R, but there's a little more to it. One formula we can use has 1 minus R to the n in it. That's a valid formula that you can use. However, there is a second formula that I prefer for doing finite geometric that doesn't rely on this little n. See, here we need to know the number of terms, and that's sometimes difficult when all you see is the last term, un. You don't know how many terms there are. I mean, you can figure it out in a variety of ways, but this is another formula that you can use. It takes u1 minus the last term times r over 1 minus r. So you still have that old u1 over 1 minus r component to it. That's very similar to the formula we used up here. However, it has that minus un times r. And the way I think of this term is it's the term after the last term. So if you continued this pattern, 3, 9, 27, 81, eventually you get to 729, you need to figure out what the next term would be by taking 729 times 3. Okay, so take 729 times 3. 2187 is what the next term would be, and that's what goes in that little cloud there. So to find this sum, it's going to be the first term minus what the next term would be after the last term. Again, 729 times 3 would be 2187, and on the bottom you have 1 minus 3. So the sum here is 1092. If you're doing this on your calculator and not getting the same answers as me, make sure you're using parentheses on top and bottom. Finally, in the middle one, we have an arithmetic series. And if an arithmetic series is not finite, it will not have a sum. It must stop in order to have a sum, and this one does at 66. So the sum of this arithmetic series is the number of terms times u1 plus un all over 2. So it's going to be 11, because there are 11 terms. If you're counting by 6, 12, 18, 24, 66 would be the 11th term. The first term is 6, the last term is 66, all that over 2. And the final answer there should be 396. Okay? So that gives you one example of each of those types of series. Let's look to the other problems here. What I'll do here is I'll just put in the final answer, and you go ahead and work those out on your own. Okay, the answer to the fourth one here should be 21.3 repeating. That is an infinite geometric. The next one is 439.3125. That is a finite geometric. The next to last one is 72. That is a finite arithmetic series. And then we have 50 for the last one, and that is an infinite geometric series.